Hello friends, welcome to the one and only example. I am Ankit Sharma, your mentor for reasoning ability. My dear students, you must have heard about lot of shortcuts in reasoning. Today we are going to discuss one of them, and that is counting of diagonals. My dear students, let us immediately start. Now if I talk about the number of diagonals in a triangle, so you all are well aware that in triangle there is no concept of diagonal. So the number of diagonals in a triangle is 0. That is nil. If we talk about the number of diagonals in a rectangle, so it's 1 and 2. So the number of diagonals in a rectangle is 2. Similarly, now if I take, this was a four-sided figure, rectangle. Even in square, it's 2 only. So now if I take a geometrical structure with 5 sides, that is the pentagon. So what will be the number of diagonals? Obviously it will increase, but how much it will become? Let us do the counting. It's 1, 2, 3, 4, and 5. So the number of diagonals in a pentagon is 5. What if I take a structure with 6 sides? That is the hexagon. So the number of diagonals now in this case will be 1, 2, 3, 4, 5, 6, and 7. Finally, 8 and 9. So the number of diagonals in a hexagon is 9. But now you all will realize that simultaneously when we are increasing the number of sides in the structure from rectangle to pentagon to hexagon, then heptagon, then octagon, and so on, when we reach till decagon and even further, if I go by this process of manually drawing the diagonals and then counting, I will do two mistakes. One, I can overcount the number of diagonal, or I can skip any diagonal. So it will be time consuming, as well as there are high chances of error. So now let us eliminate such issues, and now let us focus on the logic. Everything has got certain pattern. So now what is the pattern in this? My dear students, have a look at this. Now if I go by the same method in a heptagon or in an octagon, I will be totally confused. Similarly, if I go in a 9-sided structure or even take a decagon, which is 10-sided, if in the same method I go that I draw the diagonal and count, obviously those two mistakes which I said, I can overcount the diagonal or I can undercount the diagonal. In any case, the answer will be wrong. So now let us see the logic. What is the point over here, my dear students? Now have a look at this chart. In a triangle, there are 3 sides. Number of diagonal was 0. Now, if I take the 4-sided structure, rectangle or square, there the number of diagonals were 2, if you can remember. So there is an addition of 2. If I take a 5-sided structure, that is the pentagon. So in a pentagon, the number of diagonal is 5. There is an addition of 3. In a hexagon, the 6-sided structure, the number of diagonal is 9. So there is an addition of 4. So you can see over here, my dear students, it's plus 1. Here it's again, you can see plus 1. And now further, if I see in a heptagon, 7-sided geometrical structure, the number of diagonals is 14. So again, you can see over here, it's plus 1. Similarly, my dear students, over here, it's plus 5 now. Now in an octagon, 8-sided structure, the number of diagonals is 20. Again, you can see over here, the second difference is plus 1. This is the first difference. This is the second difference. So even this is in series, plus 2, plus 3, plus 4, plus 5, plus 6. Now in a 9-sided structure, now you have understood, it's plus 7 and it will be giving you 27. Now similarly, in a 10-sided structure, decagon, the number of diagonal will be now plus 8 and you will be getting 35. So now this is again a very quick method. By this method, there is no need of drawing a decagon, no need of drawing octagon or heptagon, whatever, in order to count or calculate the number of diagonals. No chances of error. But still it's time consuming, because if I give you a structure like decagon, you will have to continue the series till 10-sided structure. Okay, so now let us eliminate even this lag, and now let us be the quickest in giving our response. in such kind of questions. So my dear students, the direct formula to calculate the number of diagonals in a geometrical figure like that we discussed is n into n minus 3 by 2, where n is the number of sides in the figure. Let us check this. My dear students, in a triangle there are 3 sides. So if in a triangle, my dear students, there are 3 sides. So now let's put n's value 3. So 3 into 3 minus 3, 0 upon 2. It will be giving you nothing, 0, which is the number of diagonals in a triangle. Rectangle or square which has 4 sides, put 4 over here. 4 into 4 minus 3, 1 upon 2. So the moment you solve it, you will be getting 2, which was the number of diagonals. All right. Similarly, my dear students, for a pentagon, the moment we put 5 sides in a pentagon, 5 over here, 5 into 5 minus 3, 2 upon 2, and the moment you solve it, you will be getting 5 diagonals in a pentagon. If we talk about a hexagon, which has 6 sides, put 6 over here, 6 into 6 minus 3, 3 upon 2. Now, the moment you solve it, you will be getting 9, which is the number of sides in a hexagon, which is the number of diagonals in a hexagon. So I hope this is the quickest method. So now if someone asks you that the number of diagonals in a heptagon, so obviously you will be putting 7 over here. So 7 into 7 minus 3, 4 upon 2. The moment you solve it, you will be getting 14 diagonals in a heptagon. In an octagon, 8 sides, so we will be putting 8 over here. 8 into 8 minus 3, 5 upon 2. The moment you solve it, you will be getting 20 diagonals in a octagon. In a 9-sided structure, 9 into 9 minus 3. 9 into 9 minus 3, 6 upon 2. The moment you solve this, you will be getting 27. And in a decagon, 10-sided structure, 10 into 10 minus 3, 7 upon 2. The moment you solve this, you will be getting 35 diagonals in a decagon. And hence, this is the quickest method. I hope you understood it. Thank you. Have a great day ahead.